All right, everyone, welcome back. Thank you. Again, I'm Jacob Mullins with Microsoft. I work with our startup developer group here in Silicon Valley. And so if you have any questions about BizSpark, our startup program, or Azure, and how you can get on and start building on that, let me know. But thank you for coming with us again this afternoon. We have about 600 people online right now watching and tuning in from around the world as well. So if you want to ask questions, again, you can tweet with the hashtag CloudSlam or hashtag CS11, or online you can also ask questions in the live stream group, and we will filter them up and bring them up. So I'm thrilled to have and introduce Don Ferguson, who is the Executive Vice President and Chief Technology Officer at CA. He's responsible for delivering common technology services to CA's business units, ensuring architectural compliance and integration of the company's solutions and products. Tasked with promoting technical excellence at CA and further developing the company's technical community, Don is the chair of the CA Architecture Board and a newly formed Distinguished Engineer Board. He also serves on CA's executive leadership team, which supervises the business and technology strategies for the company as a whole. Before assuming the position of CTO, Don was a corporate senior vice president and chief architect. In this role, he defined the direction and technical evaluation of CA products. Don placed special emphasis on product integration and support of new technologies like business product modeling, web service standards, and Web 2.0. Prior to joining CA in 2008, Don was Microsoft Technical Fellow working in the office of the CTO. He worked on various projects exploring the future of enterprise software with a special emphasis on web services and internet application platforms. Don began his career at IBM, where he worked for 20 years. In 2001, Don became an IBM Fellow, IBM's highest technical honor. IBM has approximately 50 IBM Fellows in the 150,000 person engineering team. Earlier, he served as chief architect for the IBM Software Group, where he focused on design issues and initiatives spanning the DB2, WebSphere, Tivoli, Lotus, and Rational product families. During this time, Ferguson also worked on a number of SOA and web service initiatives, specifications, and standards. Don has also held the title of chief architect for the WebSphere product family from its inception until becoming IBM Software Group chief architect. Don earned a PhD in computer science from Columbia University. He's contributed to approximately 30 technical journal and conference publications and has more than about a dozen patents. So obviously we have an expert with us. So please put your hands together and welcome Don Ferguson.
Thank you very much.
Thank you. Cheers.
Normally, after an introduction like that, I can't actually work the pointer thingy. It's a very impressive introduction, and I was really proud of myself until Obama got elected president, because he and I went to Columbia together. So now I actually feel like a major loser. Also, if you get a tweet from somebody asking if they can have Reese's peanut butter cups when they get home, it's my daughter, and tell her the answer is no. My hypothesis in this presentation is that programming as we know it and the role of programmers is going to virtually disappear, and cloud computing is what's going to cause that. Almost by definition, if there's no software, there can't be any programming. That's obviously a very facile thing to say, but I'll try and walk you through why I think that's the case. I'm famous for not making any sense. I would go home and talk. He's nodding right here. We must have worked together. I used to go home and tell my family, I gave another presentation today. There was stunned silence at the end. Nobody really understood what I was saying. It's because I helped design WebSphere, and my daughter said to me, "No, Dad, you're just confusing." So if there's any questions while I'm presenting, please don't hesitate to raise your hands.
I was just identifying with
you. Okay, I feel better now. You never know. So I'm making predictions about the future, and to calibrate the accuracy of my predictions, I just wanted to walk you through. This is a graph of time and accuracy of prediction over time. So it starts at the bottom with the developers who are focusing on what they're actually writing and building now. Product management is thinking about the next couple of releases, what the requirements are, what we need to put in the product. So almost by definition, they're predicting the future about a year to 18 months out. Then you get distinguished engineers that are thinking about strategic trends, how the technology is evolving, what the future is actually going to look like. You get IBM fellows a little bit farther out. Then you get Nostradamus. And then you get me. So that's an estimate of how accurate it'll be. Today, in the status of the cloud is when people talk about cloud computing, they almost exclusively focus on infrastructure as a service. So Amazon Elastic Cloud Computing, building scalable grids with VMware, distributed hypervisors. Or they focus on software as a service, things like Salesforce.com. This has actually moved into the IT management space with something like ServiceNow. But there are two layers in the middle that I don't think get enough attention. One of them is platform as a service. People were talking about Azure before. Force.com is another example. I think that over time, platform as a service is going to be the dominant factor. It's going to effectively kill infrastructure as a service. Infrastructure as a service will continue to be there, but it's going to be to implement the platforms within a cloud provider. And there's also another layer that people typically don't see on their cloud layering. So normally if you look at a picture about cloud computing, it'll say infrastructure, platform, and software. But there's a concept out there of something programmable web, web callable interfaces. FedEx, for instance, has the ability to actually call web service APIs to schedule printing, logistics, pickup. Dun & Bradstreet has got APIs that you can call on the web to do things like credit check or get financial background information. I call this business services as a service, which has the unfortunate acronym of BS as a service. But you're seeing this thing increasingly emerge. Gartner is also beginning to think about this. This is a clip from one of their case studies. They surveyed several enterprises about what they were doing in cloud. And I think if you looked a while ago, it would have been mostly around infrastructure and app infrastructure or business services. But you can see that they're actually starting to see the emergence of things like application services and callable information services. This case study is actually quite interesting. The URL is up there, but they've actually gone through and talked to a lot of enterprises, trying to come to understand about how they're incrementally going to move to cloud computing and what technology they're going to use. It's a very fascinating study, and it's quite a good piece of work. Now, I'm asserting that the programmable web and APIs are out there. I have clip art, so screen capture, so it must be true. But this is the SOA story taken supersized. If you remember when we started doing things like web services, SOA, we were doing things like enterprise service buses. The elevator speech was, take all of your enterprise interfaces to either applications or data, encapsulate them with web services, put them in a registry and repository, and use high-level metaphors to stitch them together to do business process modeling in BPMN, to build a portal with a portal editor and customizer. Well, this story actually was fulfilled, but today we call that the internet. The argument for SOA, the elevator speech for SOA was, basically you don't have to write code. Any interface you're ever going to need is somewhere in the enterprise. Just normalize it in web services, and everything else from there becomes composition. The same story applies to the web, only with some extra zeros on the end. It's very hard to think about writing an application where the API that you need isn't out on the web somewhere. And these are just some statistics. I think we're seeing widespread emergence of application platforms and callable APIs. In their aggregate, they're going to meet 95% of any application requirements that you have. 95% of the application, 95% of the code's out there somewhere. And tailoring or assembling the remaining 95% isn't actually programming. It's just using another application associated with the API or application, and I'll give you some examples of that in a second. But if you go out, there's some interesting statistics. a fascinating site is programmableweb.com. They have 3,000 web callable APIs. They have libraries for calling them. A lot of these things are things you would think of as kind of at the margin, but many of these are things we would think of as mainstream business APIs, calling CRM, doing credit checking, calling things like Dun & Bradstreet or Federal Express or other sources. There's 350,000 apps at the App Store. If you're trying to interact with a set of applications, it's got to be very hard not to find an app that almost does what you want it to do. So historically, we did things like client server, or we built portals that pulled together information that would give you a role and task specific workspace. You don't really need to do that anymore. There's got to be an app out there somewhere that's almost right that you just need to customize. Drupal, which is an open source content management and collaboration system, has about 8,000 pre-built modules and plugins. If you're trying to set up a content management portal focused on a specific business problem, it's going to almost be impossible to find something for which there isn't a plugin. And if you just go out and even send a query on the web or post something, someone's going to build the plugin. Using a plugin to customize the site isn't programming. It comes with another set of web pages that are how you set up the content structure, what are the rules for submitting things, what are the workflows. So the application, the plugin, is something that you use, but there's another application on the side that allows you to customize it and tailor it for your specific business problem. There's almost 200,000 applications built on Force.com. And platforms are emerging. We tend to look at Amazon Web Services as elastic cloud computing. But I spent a lot of my time in my career working on things like enterprise service buses, message queuing app servers. Most of the APIs out there, PubSub, simple message queuing, relational data, as well as higher layer things like website analytics or historical pricing information, are just there to be called. So if you're trying to solve a problem and you can't find a set of APIs or a set of platforms that can do it for you, you're not trying hard enough. This is the classic picture of a web application server. This is J2EE. If you looked at ASP.NET, you'd see something very similar. There's a portal page which is aggregating information and interfaces to applications. It's coming in over the cloud, going through a front end. There's some JSPs and servlets that are rendering and controlling the front end. There's an EJB container where you're doing the business logic, a database obviously that's holding your data. It's an enterprise service bus. And then you have existing or back-end applications, SAP, maybe you've got some stuff on Windows Server, you've got a mainframe out there somewhere that's running your traditional online banking or mainline transaction processing. But what was happening is we assumed that if you were going to assemble this thing together, if you were going to give somebody a task-specific page that had the information and the interfaces, you were going to assemble it here. So you're going to go gather the information, pull it together, bring it into a workflow or portal, and deliver them the page. What you actually see happening in applications is that we're going back to where we were when we did client server or when we did two-tier. Now the browser, once again, is the integration platform. There's been some statistics out there looking at how browsers interact with systems. Across 3,000 companies, the number of sites or APIs aggregated into the browser is about 9. So the model that we had previously, where we assumed we were going to pull all this stuff together for people in applications in the data center or in the server side, in fact, isn't happening. People are out there pulling them together by doing various things, Google, just tabs, whatever they're doing. We've been here before. We used to have a saying in IBM, "Vuja de" is like deja vu. I think I've been here before, and I'm pretty sure I didn't like it then either. But we're going back to the case where we're seeing the end user pulling together the APIs and the data. those of us who assumed that inherently the right design choice was to put together a middle-tier integration server and app server, we're going back to the case where there's just thousands and thousands of interfaces and data, and it's the end user that's pulling it together. And it's getting bigger and more complicated with mobile devices. There's 300,000 iPads that have been shipped, Droid phones. So this is just going to explode with the prevalence of things like iPads that are pulling it together. So mobile devices are going to reinforce this trend. One of the things that is scary if you're an enterprise is, in some sense, you've basically lost control of your user interface. People are not coming in to interact with you necessarily through your corporate portal, or the things that you think of as your channel to employees or consumers. They're coming in through apps that you might not have even known existed, things that they got from the App Store. Now, it's tempting to think, hey, I'll just stop that. But if you support an interface, Ajax calling your site, even HTML navigation, you're scriptable. People can build mobile apps that are going to talk to you. You can't tell it's not a browser. So the trend, I think, if you look at enterprises or businesses that put interfaces out on the web, in 5 years from now, the concept of having a website is going to seem silly. Right? Someone's going to mash and pull your stuff together. You don't control your user interface anymore. You are somebody an enterprise just becomes a site that offers APIs and data and feeds that people can call, and they on the other end are going to figure out how to put it together in the application. Another trend that's reinforcing this is the concept of a situational application or a good enough application or an ad hoc application. This is just a clip from Wikipedia. It's a good enough application. It's typically created within a small group of people. It's targeted at a very specific problem. The problem might be short in duration. Requirements for robustness, mission criticality of it aren't as great. And there's a couple of scenarios that motivate this. So think about the case where Don is traveling from New York to Seattle through Dallas. This happened a lot when I worked in Microsoft. And his flight into Dallas is late, and he misses a connection. Well, typically what happens is when Don gets off the airplane, he has to go find a place to sit. He has to start making phone calls, going to websites, sending emails. He has to book a new flight. Often that involves going up to somebody and talking to them. I may have to change a hotel reservation. There could possibly have been a car that was picking me up that now needs to know I'm not getting off the plane. I have to send emails. I may have to make phone calls. I may have to call my assistant and yell at her, why aren't you online at 1 o'clock in the morning? I'm stuck in Dallas. This could have happened while I was in the air. I did not have to wait. The system didn't have to wait for me to get off the plane and take care of this. All the information that I would have needed to make this work, to react to this while I was on the plane, is out there. American Airlines, flight stats, the FAA emit feeds. They tell you what's happening. Planes are late, planes are on time, flights are canceled. There are web interfaces to calendars. You can post things on Facebook telling everyone that you're late. There are sites that have callable APIs for doing things like changing dinner reservations. OpenTable's an example. So I could have easily written a simple bot that just watched the feeds and had very simple rules that would react to the feeds and take actions, post things on Facebook, go and try and rebook me on an airline. Now, this is never going to handle all of the problems, but even if it handles 80% of the issues, it makes my life a lot easier when I get off the plane. It's an improvement of me doing this all manually, of basically being this bot. And it'd be totally awesome. This thing goes viral. You share it with your friends. You give it to them. It's basically like a document that you share. These are some examples of mobile apps out there that are starting to do some of this. This is Flight Track, which people use. It's a new business application. This thing is, from my perspective, is an application that I've never received from an employer, but as far as I'm concerned, is mission critical. Almost everybody I know in the business world uses an application like this, and we view it as being mission critical, but it's something that we just found out there. And you can see that this is actually evolving. The company that does this offers apps for boarding passes. You can actually go and look and book for hotels. You can manage your reservations. So it's likely that when I'm trying to solve this problem, I don't even actually have to write the bot. There's probably something out there that's almost right, and all I really need to do is to configure it with things like which airlines do I use, what my frequent flyer numbers are, what my preferences are. A second, more mainline business scenario is Don works for an insurance company and he sees on the Weather Channel that there's going to be a terrible storm with flooding. An obvious question is, what's my insurance company's liability? Well, what I would do or could do is I'd log on to weather.com and I'd go get the rainfall forecast by zip code. It'll tell you how much rain it thinks it's going to be by zip codes. There's a site out there with a programmable API, Environmental Systems Research Incorporated. If you give it rainfall in areas, it's got historical data, geospatial databases. It'll tell you how deep the water's going to get, what the flooding's going to be. I could then go into the company's property and casualty system to find the properties that are in areas where there's going to be a lot of rain and flooding. I would load it all into the spreadsheet, do some calculations, and then email the spreadsheet to the executives telling them what I think is going to happen. And then I would go back to step one every hour. So I'm basically doing this over and over again. I'm a workflow engine. Well, whoops. Another thing I could do is I could just go set up a Drupal site with some pre-built plugins, including feed readers and scripts on the feeds. I could write some simple scripts that actually go to the National Weather Service and get this information, or I could use something like Yahoo Pipes to take the information and mash it together. I could do a little gadget or a little screen scraping that'll call ESRI to get the information. I'll go into the property and casualty system through REST interfaces or web services. I'll load this all into something like a spreadsheet, do some simple calculations, and I'll put it up on the website so that it's updated periodically, and every time there's a change, it itself emits a feed that goes into the Outlook feed reader or something else that people are going to use to find out what the risk is. This becomes a reusable IT asset. Initially, I would have done this just because doing this over and over again was annoying, but presumably there's more than one storm. This now becomes something that actually grows up virally, and it itself becomes a mission-critical enterprise app. So what is the message here? Nothing good can happen when I send an email, but that aside, there's a generational transformation in computing. Professionals that are entering the workforce have basic programming skills. I take martial arts. The teenagers would tell me, they knew I worked for IBM, they would tell me about the websites they put up, what they had learned to do with Python. One of the students went in and wrote a Microsoft Access app. Until she wrote this app, we had a logbook when we came into class. We had to sign it in. The instructor would basically say, Tuesday this date, and we had to sign in. It was the way Dickens would have done it. She came in, wrote a Microsoft Access app, connected it to a barcode scanner so we had IDs. It would scan it, put the information in, keep track of how many classes we had taken, and send us emails telling us what our bill for the month was and when we were available for the next exam. I was shocked because when I started, that was mainline Kix COBOL programming. I mean, you basically needed to get a serious-ass programmer to do that kind of thing. This woman went to college and was a communications major. She didn't study technology, but she was able to do this, and she was going to go into the workforce. These capabilities, combined with the interfaces out there and the ability to get things like a Drupal site for $10 a month. You know, I have a Drupal site where I keep things like a blog and work on books. I get it for $10 a month. It results in a completely new application model, situational applications. So what you're going to see over time is a complete change in the nature of applications in the business world. So in the x-axis, if this is size of the application and the functionality, so this is an online commerce, Web0 commerce suite. You know, this is a CRM system. The number of those applications relative to the size is obviously going to decrease. On the other hand, when you look at the low end, simple, easy, quick, it's going to explode. The total number of applications is going to go up exponentially. And moreover, the total number of users using those applications is going to go up exponentially. So taking a step back and thinking about what this means for IT, today, if I'm running a data center, I have 1,000 servers and various blades. I might have 10 apps, HR, online commerce, customer self-service. I pray to God they don't change more than every 6 to 9 months because I have to go through an entire release and QA cycle. I'll have thousands, if not millions, of users coming to my commerce site, coming to my banking site. And my issues are things like availability, performance management, structured change processes. If you think about the mobile world and the situational world, I'm not going to have any servers. It's all going to happen out on the cloud somewhere. I'm going to have 100,000 applications. They're going to change every 2 or 3 days. Small groups of people are going to be putting them together. It generates a whole new set of things to consider. Think about governance for a second. Today, what happens in the security for enterprise data is you control who and log and audit who accesses the data so that later on you can surface a compliance report, who accessed this data. But think about a situational application. You know who accessed the data, but they did some computation with it. They computed an interest rate on a loan. That thing's changing. 6 months later, when somebody comes back and says, I see the data you accessed, but how did you actually get that answer? What was the code you used? The answer, well, I don't know. It doesn't exist anymore. Isn't a good answer. You're going to get sued. You have to start governing and auditing it. In some sense, the program is data too. So if you think about the mission statement about IT, it's provide a mission-critical IT environment for my core business processes, but also provide a platform for 100,000 rapidly changing situational applications. The only way you can do this, whether you're a managed service provider, strategic outsourcing, or enterprise IT, is you're going to actually have to go to the cloud computing for the long-tail applications and platform as a service, callable business services. Some terminology. IT exists to support applications. That's what drives revenue and efficiency. We sometimes use the term composite application. Any non-trivial application is a composite application. If you think about a commerce app, it's got a workflow process for fulfillment. It's got a set of business rules for implementing discounting and pricing. It may have some algorithms to figure out how to optimize a marketing campaign. This, in turn, runs on a composite IT system. It's got a database server software installed on a blade in a blade center. It's all connected together with some kind of switch. And it's software, application servers, MySQL, underlying hardware servers. If you've got composite applications, the obvious question is, well, how do I move them to the cloud, or how do I use the cloud to do this? This is just a screenshot from the service component architecture. It's one way to think about assembling applications from parts. You've got a loan system, a process for actually working chunking the loan application through. You may have to go to customer information. There could be an approval step. It's tempting to think, well, I need to do this or change this. Why don't I go out and get it done in the cloud? To implement this today, you may have to write a BPMN or BPEL process. You may have to go in and do some kind of state machine to keep track of what's the state of the loan. You may have to go in and do some rules, interact with the content management system. Code goes here. You have to write portlets. The cloud's not going to help you do this. The cloud doesn't help you write applications. What the cloud does is it helps you not write the application. Instead of building a portal, I can go up and set up a Drupal site, put some plugins in it. If I want to track things like order, I don't need to write an order management or order tracking. I just make some calls into Amazon. There are all kinds of content management APIs out there that you can call to do content management CRM. I don't need to do the credit check. I just call Dun & Bradstreet or some other firm to do that. If I'm actually going to deliver things, like I have to deliver the physical pieces of paper, which is required by the law, instead of going in and doing a logistics mailing application, I'm just going to go and call the FedEx APIs. So most of these things are just calls. The real question is, how did I put them together? There's a bit of integration work here. That's what app servers did. That's what WebSphere Process Server does. That's what BizTalk.net does. I can go put that on Force.com or somewhere else. But it's tempting to think I actually need to write code to do this. Well, like I said, it's hard for me to believe you can't find plugins in a Drupal site that are close enough for what you need for the user interface. And there's 185,000 apps in the Force.com space. There's got to be something out there that's pretty close. If it's not, you are an extraordinarily unlucky person. Don't fly from New York to Seattle through Dallas. But even if there isn't, customizing this thing really isn't programming when you think about it. The way Force.com works is there's the user interface, but the application, all of the logic, all of the data, all of the rules, all of the processes are themselves data. So there's people who use the application, and then there are people who use the application to configure and customize the application. You very seldom write code. So you find people, let them use the application, and if you need to tailor or customize it, you go find your daughter, and you have her do it for you. She'll go in through the meta application for editing the application, and then she will go and update that, and you'll get the application that you need that composes and assembles things together. If you go and look at the interfaces to Force.com, there's a form-like thing for building forms and for building pages. When you're using this, you're basically using an application that just looks like the application that the person is going to use. There's a similar form for laying out the data. There's one form for submitting the purchase order, canceling it, getting the information. But there's another form for defining what the purchase order means. There's a PowerPoint clip art-like approach to actually building a workflow. And there are Excel-like things that are out there for actually building the rules, the events, the triggers. So if you can use an application, you're a programmer. My daughter edits Wikipedia. She's 14 years old. When she's 18, she's going to be able to do this. So what is on the cloud? Well, the fundamental construct is the container. Application parts go into a container today. A BPEL process goes into a BPEL engine, and you configure the properties of the engine. This is basically a document. A WAR file goes into an app server, and you configure the properties. So what's really happening is the composite is a set of containers, and there are simple tools for editing the thing that goes into the container and simple tools for actually configuring it. And then transactions and business requests flow through this. So what the cloud evolves to is a giant set of people who are offering various types of containers that other people are pulling in, assembling together, configuring to offer new containers. So when Senator Stevens said that the internet's actually just a bunch of pipes, he was close. It's actually just a bunch of buckets. But what happens is this new economy is people offering these configurable containers that'll hold or offer services. Now, there's a management dimension of this. How did you assemble the thing? How do you secure it? How do you track the end-to-end policies? You can do this, you can do the same thing. If you view it as a set of containers, you can pull them into a composition tool. People can come in and use a Visio-like experience to wire and assemble and configure the containers together. Since the containers all have the same basic structural model, you can drag and drop it down on a hypervisor. Only this hypervisor hypervises the cloud. People often use the phrase cloud in a box. They want a cloud in the box. Where you're going to go is you're going to get the whole cloud in a box. You're going to get something that looks like VMware, but only for the internet and not the hardware. So kind of summarizing it, the current cloud focus on infrastructure as a service and SaaS is way too short-sighted. The cloud's inevitably going to be a container-like model. It's going to be containers for APIs, containers for business functions, containers for data. There's a simple PowerPoint and Excel-like set of tools you can use to pull them together, configure them, put things in it. And the cloud isn't a cloud of infrastructure. It isn't a cloud of SaaS. It is a cloud of applications. And this is what's going to be automating the economy. 99.5% of all the business value that you get for doing things like click to cash or efficiency is going to come from billions of applications that are like documents that are produced with almost no programming. Now, I've mentioned my daughter on several occasions. She's quite insistent that this is actually what's going to happen. So that actually is my daughter at dinner, and she is capable of doing this. So programming as we know it in the evolution of the cloud is basically going to make programming as we know it disappear. And in my opinion, that's what cloud computing is. So I guess we have a minute for a couple of questions. I'm quite used to stunned silence, so don't actually worry about it too much. But are there any questions in the room? You're either really tired and stretching or you have a question. Go ahead.
The question I have is, do you see the author of the application then charging the recipient of the revenue or the cost structure?
Yeah, so the question was, do I see the author of the application charging, the obvious question is, how do you monetize this? And the answer is, I think you monetize it kind of the way the App Store works. When you get things for $1, you just do a lot of them. Or it's almost like clip art. I mean, there's lots of clip art out there. There's lots of Excel templates out there. It is a model in which the cost of anything is very small, but you sell a lot of them. The other way to monetize it is that you can surface the application, but the other dimension of this is surfacing the API. If you have an API that's very valuable, you basically meter the calls, the value of what you're offering. So there's kind of two ways to monetize it. One is the clip art website template model, and the other one is an evolution of the way it works today. It's per request. If you think about the way a travel agency works, they monetize it per request. This is just automating it. It's going really, really fast. So since it's more efficient, you charge less per request. So I think those are the two ways to monetize it. Is there another question?
You mentioned about the application, composite application. Is that like a software organic architecture going to the cloud, server going to the cloud? Also, you mentioned about this kind of architecture. It's more like a mashup. You think in the future of the application of programming?
Well, yes, I think composite applications are going to go to the cloud. Today, people build, in the business world, if you have web service APIs or a standard encapsulation of all your APIs and data, there's 4 basic types of composite. There's process-centric, ka-chunk, ka-chunk, ka-chunk. This is how I open the account or fulfill the purchase order. There's on-the-glass, portal. Somebody's trying to accomplish a task. I'm going to go and give them the portlets. There's event-based. Apps emit events. Other apps react to them. And then the final one is data-based. You're pulling the data together. Today, people think about mashups being inherently primarily visual. But you're beginning to see the emergence of things that are non-visual mashups. Yahoo Pipes is my favorite example. But Salesforce.com has interfaces for doing integration of external systems, and it's got a workflow tool. So mashups will also emerge, but in the non-visual layer. So composite applications today are going to go out, and the cloud is basically the app server. So we have one more question. So one more.
Do you think businesses will be comfortable moving their business logic to the cloud?
So the question was, do I think that businesses will be comfortable moving their applications and data to the cloud? Intellectual property. So what's I'm not very bright. What's an example of intellectual property?
Well, right now it resides in my iCloud or inside. I don't want some intellectual property that belongs to my company to go to the cloud.
Well, so I would argue to some extent that your intellectual property does go to the cloud. People routinely send things through the email that are very sensitive. Even if you don't trust email, presumably you FedEx stuff that is incredibly sensitive. People put things in Iron Mountain. The fundamental basis of security is trust. So the question is, if Bank of America says, I'm going to offer a cloud service, you trust them with your money. You probably trust them with your code. Sort of the same thing with Intuit. So it's the trust model. And people take trust for granted. We trust the phone system. We trust FedEx. We trust our banks. I mean, I was having this conversation with my girlfriend, and she kept insisting that, this wasn't going to happen, and she wasn't going to trust this. And it's like, do you have any idea how much data the hotels have about you? You trust them. Why don't you trust them when they say that you've actually got a little, app in your hotel room that's doing stuff for you? They already have the data. So it's trust, and yes, I think the trust will actually emerge. But one of life's universal axioms is those who get in front of the web get run over by the web. Things happen on the web today that we would have never believed was going to happen. And that happens in the entire, everywhere. When you go from terminal to terminal in Dallas-Fort Worth, you get on a train. The train doesn't have a driver. In 1930, if you had told people who ride on a train that people were going to get on a train that didn't have a driver, they would have put you in a hospital. So things that we think of as kind of risky eventually get to the point where it's just taken for granted. All right, we can wrap up because we have to let the next speaker on. Thanks.
Thank you.